Hi everyone, welcome to our compiler design project. Today we will be talk about how to create a compiler. Team members are
I am Merve Polat.
and I am Aleyna Narin. Lexical analysis. Lexical analysis, also known as lexing or tokenization, is the process of the converting a sequence of the characters in a program into a sequence of tokens. A token is a small unit of meaning in a programming language, and it can be a keyword and identify a constant or a symbol. For example, consider the following statement in a hypothetical programming language. ID is equal ID plus integer. A lexical analyzer might convert this statement into the following sequence of tokens, where ID represents an identifier, a variable name, integer represents an integer, constant, and equal, plus, and semicolon are symbols. Lexical analysis is usually the first step in the process of compiling a program. The output of the lexical analyzer, a stream of tokens, is then passed to the next stage of the compiler, which is usually the syntax analysis phase.
What is a parser code? A parser is a program that reads input in the form of a sequence of tokens and determines whether the input is a valid sentence in the language that the parser is designed to recognize. The process of determining whether the input is valid sentence is called parsing. The output of a parser is usually a parse tree or an abstract syntax tree. A parse tree is a tree-like representation of the input that shows how the input can be derived from the grammar of the language. An abstract syntax tree is a simplified version of the parse tree that retains only the information needed to generate code or to perform some other test. A parser is typically implemented as part of a compiler or interpreter for a programming language. It reads the source code of a program and checks that it is well-formed and follows the rules of the language. If the input is invalid, the parser generates an error message indicating what's wrong with the input. What's a compiler? A compiler is a program that translates source code written in a programming language into machine code that can be executed by a computer. The process of converting source code into machine code is also called compilation. When you write a program in a high-level programming language, you can't run it directly on a computer. Instead, you have to use a compiler to translate the source code into a machine code that the computer can understand and execute it. Compilers are an important part of the software development process because they allow you to write programs in a high-level language that is easier to read and write, and then translate those programs into machine code that can run efficiently on a computer program. How to create a compiler? Creating a compiler is a complex task that typically requires a strong background in computer science and a deep understanding of programming languages. First of all, determining the source code and target language of the compiler. The source language is the programming language that the compiler will read, and the target language is the programming language that the compiler will produce. And then designing the syntax and semantics of the source language. Implementing a lexical analyzer, implementing a parser, implement a code generator, and test the compiler to ensure that it is correct and generates efficient code. This is just a high-level overview of the process, and there are many details and subtext involved in each of these steps. It is challenging but rewarding project to undertake. Here is our lexical analyzer code and some basic rules for our Jupyter compiler. Here is our parser code part 1, parser code part 2, parser code part 3, and all parser code together. Our syntax, calculation syntax. For summation, we use int plus int. For subtraction, int minus int. For multiplication, int multint. For division, int div int. For square, int squared. For mod operation, int modulus int. For loop syntax. In order to operate for loop, we use loop for keyword and we use camel case syntax. In open square bracket, we use variable minus minus or variable plus plus, it doesn't matter, and we separate them by comma variable less than integer, greater than integer, less equal or greater equal, it doesn't matter, and also still comma, and we use type of this variable, and we put tilde at the end of this line. In order to create an infinite for loop, we use ly into square bracket, and we use tilde. For while loop, we use loop while and camel case style, and we use tilde at the end of this line. For infinite loop, also we use ly keyword. For do while, first of all, we use do check and square bracket, but there is nothing inside this bracket, and loop while, and we write our condition like a is greater than 0, and we put tilde at the end of that. And for infinite do while loop, do check, loop while, ly, and tilde. For if syntax, empty if, we use first case keyword, variable if, first case, all of them is first case, and we put our condition into that first case, and we use tilde at the end of this line. And for else syntax, empty else, variable else, comparative else, we use other case keyword. Definition variable syntax. In order to define an integer, we use counting number keyword. Counting number int tilde. For string definition, char array char tilde. In order to define an integer array, we use counting number, and we must define the size of that array. For string array definition, we use char array and size of it. And here is our compare syntax. For equal, we use equal, not equal, not equal, greater than, greater, less than, smaller. And in this style, we use all of our keyword in uppercase mode. Let's look at our function syntax. In order to use a function, we use counting number or char array. It depends on the type of our function and what it returns. And also we have to use a parameter which can be integer or char. How did we build our Jupyter compiler? First of all, we create Jupyter.l and Jupyter.y files into our compiler design term project folder, and we open command line in order to operate, and we use flex operation on Jupyter.l, and we produce flex.yy.c, and we did Bison operator, and we create Jupyter.tab.c and .h, and we change our name to y, and we operate this command. We operate an executable file with this command. Here's some examples. For example, 12 plus 36, syntax is correct, accepted. For in another example, 7 squared, result is 49, and this is correct, this syntax is correct. An example for incorrect while syntax, loop while is greater than 0, tilde. All of them is lowercase, so it's incorrect. Word sequence, because it should have been in uppercase, the W uppercase. And an example for example for loops, for if conditionals, for else conditionals, we use other case, and this is incorrect word sequence because camel case we should use it. And string Aleyna is incorrect word sequence because we don't use string in our Jupyter compiler. Instead, we should have write like char array Aleyna tilde. And do while, and some equality and not equality operators, and for greater and smaller operators. That's all. Thank you.